Good afternoon, Dr. Buhaida. My name is Ying and my metric number is AP170396. This is a video for step 7, which is performing table joins. For the first, I have directly download a copy of both the datasets from the links below here. The two zip files. And then I open the QGIS and locate the data set that I downloaded just now. Then I see the layer. Look in the layers panel. This layer contains the boundaries of Kansas tracts in California. Then I right click the data and I click open attribute table. To join a table with this layer, we need a unique and common attribute for each feature. In this case, the job field is a unique identifier for each track and can be used to link this layer with any other layer or table containing the same ID. Next, I need to unzip the second zip file that I downloaded just now. Then I open in Notepad. I noticed that each row of the file contains information about a track along with the unique identifier we saw in the previous step. Note that this field is called job ID2. In the CSV, you will also note that the HG01VD01 column has population value for each of the Kansas tract. Before importing this CSV file, we need to make a minor edit. QGIS CSV imported expects the first row of the file to contain the column header and all remaining rows to contain the data for these columns. This file contains an extra row too with column label. So we need to delete that row and save the file again. After that, we can import the CSV file. I click layer and then add layer and then add delimited text layer and find the file just now. In the data source manager window, click the button and find the CSV file. Make sure you have select file as CSV format. Since we are importing this as a table, we must specify that our file contains no geometry using the no geometry. Verify that the sample data preview at the bottom looks fine and click Add. Then close. The CSV will now be imported as a table to QGIS and will appear as this in the layer panel. Now we are ready to create the table join. So I go to processing and click on toolbox. First, we need to change a default setting in the processing toolbox. Click the options buttons. In the processing options tabs, check and make sure the preferred output file name for layers for layer names is click is after that click OK. Back to the processing toolbox, search and locate the vector general. Then search join attributes by field value. Double click. In the join attributes by field value dialog, select TL as the input layer and table view choose job. Then select SCS as the input layer set 2. Then the table view tool, select the job ID 2. After that, on the join layer, click on save to job package. Then enter the name. Save. The layer name put as the join. Then OK, click run. Once the processing finished, verify that the algorithm was successfully matched, and then click close. I see the layer join. Look in the layer panel. At this point, the fields from the CSV file are joined with the Kansas tracks layer. You can choose the processing toolbox for now. So I right click and open attribute table. I see a new set of the fields, including the HD01, VD01 field containing the population estimates. Now that we have the population data in the Kansas tracks layer, we can start it to create a visualization of population density distribution. So I select the join layer and click open the layer styling panel. In the layer styling panel, select the graduated. As we're looking to create a population density map, we want to assign different color to each Kansas track feature based on the population density. We have the population is HD01, VD01 field, but we don't have the population density in any field to select as the value. Fortunately, QGIS allows us to input an expression here. So I click on the expression. Then enter the following. HD01, VD01. Click OK. Back in the layer styling panel, choose a color ramp of your choice and click classify. The visualization feels a bit cruder because of the polygon borders. Click on the drop down next to symbol. Then select the simple fill and check the transparent stroke. Now we have a nice looking information visualization of population density in California. So this is a video for step 7, performing table joins. Thank you.